Okay, today I'm going to show you how to solve a common trajectory of a projectile equation, problem that I've been doing a lot in class and feel like I could help people out with. It's a common one in books, and I'll do a few tonight, a few variety of problems that have to do with this, and hopefully it'll help you in your Physics 1 class. So let's get right to it. The problem is going to be, we're going to fire a cannon off a cliff, and the cliff is going to be 410 meters high. The cannon is going to fire off at an angle of 47 degrees and a velocity of 280 meters per second. Now, first thing you want to do in solving an equation like this is using trigonometry, use basic trig to find your Vy, so your vertical velocity component, and your horizontal velocity component. Now, to find Vy, you want, it's your velocity sine theta. And theta is just your angle you've got right here of your projectile. To find the horizontal velocity component, it's V cosine theta. So let's just plug that in. 280 sine 47. We can do that right here. 280 sine 47. And we get 204 we'll call it 0.8 meters per second. Now, to find our x, we're going to do velocity, so 280 cosine 47, and then we're going to get 280 cosine 47, and we get 190. Let's just call it 191, actually. 191 meters per second. Okay. An important thing to note when doing equations like this is, and there's different ways of doing them. The way I do it, I think, is better in the long run because it helps with your rounding, and it splits it up into one part that's a little lengthy, but then the last part is relatively easy. So when finding time, and what you want to do first is find your time. In an equation like this, use your Vy velocity and do this one first. You need to find your time to find your distance. And for this one, you're going to want, for your distance, you use your horizontal velocity. Use this one second. So like I said, what we're trying to find out is, just imagine that continues down here. We're trying to find out where this hits at the bottom and how long it takes it to get there. So like I said, we're going to find time first, and we're going to use it in terms of your your vertical velocity. So let's move down here. I'm going to copy down our Vy and our Vx again, just so you can see it. 91. Okay, so first thing you're going to do is you're going to use the equation x equals xo plus VOT plus 1/2 AT squared. VOT being initial velocity times time, XO being your initial distance, A being acceleration of gravity, which is negative 9.8. And in terms of this, it's going to be x equals Vy, which is just a starting distance, plus VYOT plus 1/2 AT squared. Now, our starting distance right here is our point of reference, so it's a non-factor. So we're going to just cross that out. It's going to be 0. It's our point of reference. It doesn't matter. Our distance, let's go back to our distance first. Distance is going to be 410, but it's a negative 410 since it's down. Oh, shoot. Negative 410. And now it's important that you have negative 410, but while important, you could probably still solve it because once you get through the equation, you notice that something was wrong, so you could probably go back to find it. And then we got our initial y. Now, like I said, up here, we want to use Vy for time, and we're going to use that first. So we use our y vertical velocity, which is 204.8 times time, plus 1/2 negative 9.8 t squared. Okay, now it should start looking like a quadratic equation to you right now. And that's how exactly how we're going to solve it. So let's set this up like a quadratic. So 0.5 times negative 9.8, I'm just going to simplify it right now, is a negative 4.9 t squared. See that? I'm just going to move it over like this. Plus your 204, your vertical velocity, times t. And to get this over, we're going to set it to 0. To get this over to this side, we need to add 410. Add 410. Okay, so now this right here should look a heck of a lot like a quadratic. And for those of you who don't remember, your quadratic is opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now, and obviously this is a, this is b, this is c. Takes a little too long to do that, so I'm going to just use a program and made my calculator so it goes a little bit faster. Hopefully you can see that decently, probably not. So I'm going to run this program. Our A is negative 4.9, our B is 204.8, and our C is 410. It's going to calculate our time. Our time is 43.7. Okay, so now we have our time equals 43.7. And after that, things just get easy. So now we have time, and like I said, we're now in the next part is the second part. Now in the second part, we're trying to find the distance of how far this lands away from the top of this. So what we're going to do is use our horizontal velocity, and it's simply this equation right here. Distance equals initial velocity times time. And our initial velocity, like I said, we need to use our horizontal, which is 191, times our time of 43.7. Distance then equals 7. Oh, excuse me. 191 times 43.7. Distance equals 8,346.7 meters. So there you have it. We have our time, how long it took the projectile to be fired and hit the ground below where it was fired from, and how far away it was it hit the ground. Now let's just go through the steps here again real quick. When solving these equations, always find your Vy and your Vx. It's paramount you find that. From there, find your time using your vertical velocity. Once you find your time, use your horizontal velocity to find the distance at which it hits the ground. Thanks for watching. Bye.